Welcome to creating a production-level automation framework in under 60 minutes. My name is Nikolay Advolodkin. I'm a senior solutions architect at Sauce Labs, test automation instructor at ultimateqa.com, and an animal lover. Here's a picture of me with a cute little goat. So, framework development is pretty hard. For anyone here that has ever created a test automation framework, you can likely agree with me that it's not very intuitive. It's hard to know where to start, and once you start, it's hard to know where to go to, what do you do, and we ultimately just stumble from workplace to workplace, picking up different skills while we're developing our automation frameworks, and ultimately 5-10 years down the line, we have the process down and complete, and we can now create a good automation framework. But what if there was a better way, a way to make it easier, a way to make it more intuitive to create an automation framework for anyone that wants to start? Acceptance test-driven automation is a development methodology designed to make the creation of test automation frameworks intuitive, simple, agile, and to help avoid over-engineering. Acceptance test-driven automation is exactly what it says. We use the acceptance tests to drive the development of the test automation framework, which will ultimately test our system under test. To use acceptance test-driven automation, we iterate through numerous phases in order to create our automation framework. We start with the red phase, where we write a complete automated acceptance test using English-like syntax and the page object pattern. Next, we will go to the green phase, where we're gonna implement that test and make sure that the test passes. No premature optimization and fortune telling allowed here. In the next phase, potentially one of the most important phases is the refactor phase. We will clean up the mess we made, we will remove duplication, and we'll remove any kind of inefficiencies. The fourth phase is back to the green phase, where we check, did we break anything through our refactoring? Afterwards, we check that our test will actually fail when it's supposed to fail. And at that point, we'll do the green and push, where we fix the test and push it into production to start monitoring our systems. So, what I hope to show you today with this methodology is under 60 minutes, I'm going to show you 2 UI tests using best practices. We'll code a production level framework along the way. We're going to run it through a CI system in parallel using only free and open source software. Enough talk, let's jump in and start coding. Let me show you the setup here. So you can see I have a class ready acceptance test driven automation test with absolutely nothing in it. Let me show you my solution layout. Now I'm doing this in Java simply because it's the most popular Selenium WebDriver programming language, but you can do this in any other programming language. It'll work as long as you have the guidance of your IDE. So look here, you can see my setup, just have my test and pretty much nothing else in here. My POM XML is empty besides having JUnit in here. That's really it, because you need a unit testing framework in order to be able to write automated functional tests, right? So let's go ahead and close this out. And so now let's take a look at our software that we'll actually be testing. And that's this application right here. So there are several tests. There are many tests that we can write for this application, but we always want to start with the simplest possible test. Again, we're always trying to apply agile principles and create an MVP that we can release to production as soon as possible so that it can start providing value to our teams and our employer. So looking at this application, what's the very first simplest test that we can write? Well, that's likely the login test, right? Making sure that a user can successfully log into this application. Now, just a little side note, we would typically almost never write a login test through the UI because you can test login through API, But actually, in this case, with this application, it might be one of the few times in the world where it's actually acceptable to write a login test, because this application is a dummy application and doesn't have a back end. There's no authentication happening on the back end. All of it is happening on the front end. So you can't do API testing with it. You can only do front end testing with it. So here it's actually totally appropriate. Okay. So we're going to log in and make sure that a user can successfully log in. So let's go ahead and start writing that out. So remember, the very first rule is, well, first we need to start out a test. So let's go ahead and set up a test method, and we'll say should be able to log in. Now, the very first rule of acceptance test driven automation is to write a test in plain English using software development best practices and using the page object model that we will fill in with the implementation details afterwards, right? So what's the very first thing that we're going to need? Well, we're going to need a driver, right? So let's get our driver. And for now, I'm just going to say, I'm going to have a method that is going to get our driver. Right, next, what are we going to do with that driver? Well, we're going to need a page object that we're going to use, and we are going to call this the login page. So let's go ahead and new up our login page. And of course, we'll pass in our driver. Excellent. Now with the login page, what are we going to do next? Well, we're going to log in. So let's go ahead and do that. And what are we going to need to pass in? A username, which standard user, and a password. This is a super secret password, by the way. Make sure you don't share it with anyone else. Excellent. So now we are logged in. What is the next thing that we need to do? We need to validate that the user was successfully logged in, right? So how do we do that? Let's come here and log in and see what comes up next. Well, this page comes up next, right? It has a title called products. It has a bunch of items in it. So I'm just going to call it products page. So let's use our assertions. By the way, notice the help here coming in from the IDE. That's what makes this technique so beautiful, is that you don't have to think as much because the IDE provides you a bunch of the steps and makes your life much easier. So here I'm just hitting tab and the IDE does the rest. And we're going to do login page is loaded as our check. And that's pretty much it. Assert that the login page, sorry, and actually it should not be the login page, it should be new products page. And we're going to pass in a driver, and we're just going to check that it's loaded. Okay, fantastic. So do we have a test that is trying to log in? And you know what, I realized I missed one very important piece here, is to make sure that the login page can actually open. All right, we have to open it before we can start logging into it. So there we go. So now we have a test that uses our login page to open it and log in, and then asserts that the new product page is loaded, right? Is this test absolutely clear in terms of what it's testing? When you look at the test name, when you look at the code inside, can anyone have any questions about what this test is actually checking, even if you're not familiar with our application, right? I would say probably not. So now that we have our test, the next step is to go to the green phase. So now we are going to start making all of this code actually work. Okay, now I cheated a little bit here by creating this method called getDriver and just filling it in with all of these details to create a remote web driver. Okay, don't have to use it with a cloud provider. You can do this with a local Chrome driver or Safari driver or whatever you want. I'm choosing to go this route because just from my experience, I know that testing in the cloud using a cloud provider is already drastically easier than testing locally. So I'm just going to even start there instead of starting in a small place, trying to scale out and then realizing that I have software and hardware issues, then then going to a cloud provider. I'm just going to start at the cloud provider. Here you can see that I've imported all of this, and so now this is actually complaining. So at this point, another part here, we're just going to use our IDE to fix all of these issues, right? You can see I'm just doing Option Enter to fix all of these problems with that the IDE is complaining about. Yes, let's do that. And then it's complaining about remote WebDriver, so let's do that. And then what's it complaining about here? Yeah, of course it wants to throw malformed URL exception, one of my least favorite exceptions in the world. And what else here we need to do is just change this to a test name, and we will call it sample test. That is good enough. Okay, cool. So let's see here. What is this complaining about now? Oh, of course, it also wants me to add an exception to the method signature. So let's go ahead and do that. And we are done there. Cool. So that part is okay and no more compilation issues. So now let's go here. Of course, the compiler is complaining, saying that the login page doesn't exist. So let's go ahead and use our IDE to create it, and it will automatically do all of this beautiful work for us so that we don't have to worry about anything. And boom, that's done. And so then of course it complains about the driver. Let's go ahead and create a constructor. And then since we're passing in the driver, let's go and set the driver to this driver. And of course then it's going to complain that this driver doesn't exist. So then let's create a field called driver. And fantastic, we are done with that. Now it's complaining about the open method. Of course it doesn't exist. So let's go ahead and create it. That's going to be super easy. Navigate to URL, and what's that URL going to be? Let's just grab it from here and pass that in there. Boom, done. Open method ready. Let's go ahead and implement the login method, which of course also doesn't exist. So let's do that. Standard user, and let's change these parameters, username and password. There you go. And let's go ahead and identify the elements to interact with here. So the very first thing we're going to need is a WebDriver wait class, right? Because we always want to be interacting with elements to synchronize on with WebDriver wait first, and then after we can use a find element. So I'm going to create a WebDriver wait here. Let's call it wait new WebDriver wait. By the way, notice, yeah, how the IDE is really helping me here. And the WebDriver wait, what does it take? A driver and a time. And the time, right? I think it's like in seconds. Timeout in seconds. Perfect. There you go. 10 is actually good enough for me. Now, what are we going to do here? We're going to wait for some specific elements. So let's get our web element, and let's do user name field, and then we're going to use our wait until some expected conditions. And by the way, notice again, using just Option Enter in the IDE just keeps importing all of this for me, which just makes it super simple. There's very little thinking here about what dependencies you need to pull in to do what. It's kind of more of, hey, I understand how to program, I understand the API of the software that I'm using, and now I'm just going to write the code and let the IDE handle a lot of the work. So expected conditions, and then we're gonna do visibility of element located, and then by, I don't know which locators it has. Let's go ahead and take a look here. Let's inspect that. This one has a username. Awesome. So by ID. And let's pass in username and excellent. And of course it complains that by doesn't exist. So we'll just use our handy IDE to import that. And now we can do username field, that's send keys, and then what's it going to pass in? The username. Excellent. Oh, comma. There you go. Now we need the password field. So for the password field, it's pretty easy. We'll just do driver.findElement by ID. I'm guessing it's an ID. Let's go check. Yeah, nice. Password. I've done this enough times that I should know the locators on this page by heart, but I don't. By ID, and then we need to also send keys, and then that's going to pass in the password. And if you're curious why I use the WebDriver wait here and the find element here, it's all for synchronization purposes, totally out of context for this discussion, but it is a very important discussion to have if you want to have that with me later. So now we just need our button to click, right? So then we'll do driver, find element by, I don't know that locator. I'm gonna guess it's an ID, but oh no, see, it doesn't even have it has a class. So let's do class name by class name. There you go. Pass in that. And then dot click. There you go. Excellent. So that is our login method completed. Fantastic. And now it's complaining about this assertion because it needs to import static method. Yup, let's grab it from JUnit. And now let's create a new products page. Yup, we're going to throw that there. Excellent. And automatically it gave it a constructor. How nice is that of my IDE? So smart, right? Does so much work for me. That's why this approach is really nice. Saves a lot of extra unnecessary time. We don't need a final. There you go. That's good enough for me. And let me double check if this one got a final. It did too. Let's get rid of the final. Don't need a final. There you go. And now we just need to check that it is loaded. So let's create a method is loaded. So for any synchronization points, we always want to use a WebDriver wait. So I'm actually going to come here and steal this code because why rewrite it again, right? I just wrote it. Let's reuse it. And keep in mind here, whenever I'm copying stuff, it's an excellent sign for our refactoring phase that we might need to do some refactoring. So here's our WebDriver wait. And instead of getting the username field, let's see what we're actually going to do here. Let's see once we log in. And actually, I just know the URL directly. Why waste time? There you go. So why don't we, let's see, synchronize on this inventory container, right? That's nice. It has an ID. Inventory contains all our elements. Good enough for me. So all we need to do is change this. And now let's type in here inventory container. Excellent. And don't want it going on too long. You never want to be scrolling horizontally. That's one of my pet peeves. So, okay, cool. Inventory container, we've got it. And we're checking that it's visible. Okay, cool. And now we can just return a Boolean, right? Return inventory container dot is displayed. Boom, there you go. So that'll return a Boolean if the inventory container exists. Otherwise, it'll throw an exception. So that is pretty good. There is our test. It is working, and let's try to see if it's working actually. Okay, and the rebuild had no errors, so then we can even do a Maven test. And now everything is going to work. You can see that it's running our test. And we will take a look at it a bit later. But here, just executing in the command line. And I'm happy to watch it here and see what happens. You can see build success. Test run 1, failure 0, error 0, skip 0. Fantastic. So we are good to go here, right? We went through the red phase. Now we finished the green phase where we have a passing test. Now we need to step into the refactor phase so that we can clean up this code and make it better. Now, the refactor phase is the next phase, and it's actually a very interesting phase because this is where we make our code more readable and more maintainable so that it lives for years, so that it continues to provide value for our employers and for our teams. So at this point, we basically just go through and apply any good programming principles, the dry principle, the Yagni principle, the solid principles, anything that we need to do to clean up the code, make it more maintainable, and make it more readable. So let's take a look at the test itself. Looking at the test here, I don't see anything that stands out to me that I would want to clean up. Everything looks okay right now. Of course, always avoiding premature optimization. Now, some of us more experienced people that have worked with test automation frameworks right away will say, oh, why don't you move this to a setup method, right? Why don't you add a base test method here? We all know that's coming if we've written the frameworks before, but that's the key here, is that if you have never written a framework, there needs to be an easy way to be guided into developing that framework. And so one of those rules is not to anticipate the future. We can't predict the future. And so code for the current requirements, avoid premature optimization, and as the need arises, we will do the refactoring then. So anyways, with all of that said, this is looking really good to me. Let's take a look at our page objects, and if we step inside of here, we can right away, just from the stuff that we've coded, we already know that we have this driver that's being utilized in both of the page objects. We even have this constructor that can likely be cleaned up, and we even duplicated the code. The fact that we copied and pasted it was a huge sign that it might need some cleanup in the refactoring phase. So let's go ahead and do that. So let's talk about a simple pattern that we can use in order to remove the duplication from two classes where they use the same class level variable and also they have a very similar constructor. How would we remove that duplication? Well, that's by introducing a parent class. And so let's introduce a parent class and we'll call it base page. Excellent. And of course, it's going to complain that base page doesn't exist. So what we're going to do here is create a class and then hit OK, and perfect. That's good. Next, what we want to do is get rid of this. And also, we will get rid of this and pass it in to our superclass. Pass in the driver. So, of course, the compiler is going to complain saying, hey, there's no constructor in base page, so we'll let it create it, use the IDE. Look at that. It even provided me the correct parameter. So let's do this, driver. Fantastic. And of course, the compiler is going to complain that this doesn't exist, so then we'll create it. And first, it doesn't need to be final, and second, we will make it public. There you go. Nice. All the errors in here fixed, right? Look at that, already getting cleaner, this code. Now, how about this duplication right here? We copied and pasted this into two different classes. We know that everything here is the same except this value here. So how can we clean this up? Can we probably just move this into a method that's reusable in our base page object? So let's just go ahead and do that. So what are we going to do here exactly? Is I am going to extract this part right here all into a method. So we'll use RDE again, extract method. And what are we going to call this method? Let's call it wait until visible. And we're not going to pass in a WebDriver wait, and it will not be private because we're going to want it to be protected. That's good enough. And let's go ahead and refactor. There you go. Get rid of all of this empty white space. There you go. And of course, we need to pass in the locator, which is going to be this right here. Oh. Pass in the locator. Sorry, not there. Way up here. And of course, it's going to complain that it doesn't have this parameter. So let's add by as a parameter. and we're not going to call it ID. We're going to call it locator. And then of course it complains that it doesn't have the WebDriver wait. That's because we didn't move it down here. And so let's replace this part with the WebDriver wait. Fantastic. And of course we just need to add the locator here. There you go. So look at that. Look at the duplication we've removed. Wait until visible. By D, this is all good. Sending our keys and then clicking the button. And of course, let's move this to our base page object so that it's reusable by our next page object. Fantastic. There we go. So let's take a look at our other page object and see how now our code is going to get much, much cleaner here. Look, let's go here to the products page. And now we'll get rid of this. Of course, we'll just replace this with a call to super. And then wrap that in parentheses. Excellent. What? Oh yeah, and of course, because it doesn't extend base page. That's why I love IDEs. That's why it's nice to let the IDE help you with doing your work. It can enhance your process so much. And then of course, let's get rid of this. We don't no longer need it. And we will go ahead and replace all of this with wait until visible. Fantastic. Get rid of this last paren and we'll do that. There you go. Wait until visible and return that the element is displayed. Look how much cleaner now this class is, right? Super easy to do here. And so now both of these classes look great to me. Let's come down here to the test. Everything is okay. The refactor phase looks okay. Let's try to run this test and then see what happens. So we're going to run it. Let's go ahead to Sauce Labs and check out what's going on there. Here's our sample test that's begun. It's running. Of course, it's super fast because it's a very small test. And it's running now. One thing I did notice while I was here is the fact that, look, our tests are not, they're erroring out. See how there's an error? It's not some kind of a other status like a pass or fail. And so the problem here, and look, there's even a 90-second timeout. And again, just knowing the tools, I understand that it's because we're not killing the driver. So let's go ahead and kill the driver and end our session here. And how would we do something like that? Well, we would do that using a after hook. So let's set up an after hook. And then here of course, we're going to need the driver. And we're going to do something like if driver is not equal to null, then we'll do driver, not get driver, driver.quit. And of course, it doesn't know what a driver is. That's because we only instantiated here. So at this point, it might really be good to also introduce a setup hook, right? And again, see how we're doing this when the time arises? Oh, I did a setup method, sorry. Can't talk and do at the same time sometimes. Let's do a setup method. There you go, much better. And this one will do what this one was doing down here. We can just automatically get rid of it. Bring that in there. And let's make this a class level variable by deleting that. Compiler will complain and we'll create a field at the class level. Perfection. There you go, getting that driver, quitting that driver, it's not null. By the way, if you didn't know with remote WebDriver, you should always check to see if it's null, and if it's not null, only then you interact with it. Just a little tip from something I've learned. Okay, fantastic. There's that cleanup, we're killing the driver, and so now whatever happens, the test should not error out. By the way, we don't need to throw this exception either, so let's get rid of it. And let's give another test in our green phase again, make sure we didn't break anything through the refactoring. do a Maven test. Let's pull up our results here, go to test results. Boom, there it is, another test running. And this one should not error out. It's actually going to get just a complete status because we're not passing in the test status yet. We can do that, but I don't want to do that right now. It's not necessary for us to complete our automation framework. So you can see we're getting a complete status, which is perfectly fine. And it's running in 12 seconds versus a minute 43 seconds. Excellent situation happening now. That is all cleaned up. We just did the green phase after the refactor phase, which made sure that our test was passing successfully and that we didn't break anything after the refactoring. Let's go on to the last phase, the red phase. Okay, now we enter into the final phase, which is the red phase. The phase that actually makes sure that when your test fails, it provides you an excellent message. Something that will decrease your mean time to diagnosis so that you can figure out the failure from your UI automation much faster. This is a critical phase, and unfortunately, I see it skipped a lot whenever we're doing test automation. Some of us automation engineers, we will actually have tests that never fail, which is a horrible thing to do because imagine if there's a massive bug that gets introduced into the system and your tests are supposed to be failing, but they're not. And so you have a false sense of confidence about the quality of the system until the user finds out, and then everybody gets fired. So anyways, how do we do this? Well, we can just reverse one of these conditions by coming in here, and let's change this to like inventory containers, which we know is not going to exist. And we can add a few more S's. And then we're just going to run the test and see how that looks. And make sure that it actually fails. Every test should fail. So we don't even need to go to Sauce Labs to see that run. It's going to be super quick. Here you can see we have the console output. Let's take a look at it using the W3C protocol, which is told to you here. And there it is. Okay, so look, you can see failure, red, right away usually means failure. So one test run and there's an error. Let's take a look at this error, test in error, expected condition failed, waiting for visibility of element located by inventory containers, tried for 10 seconds with 500 millisecond interval. So, and that element wasn't found, I guess. Let's take a look here. Furthermore, we're looking into the stack trace. Looking here, expected condition failed. Yeah, so this, what do you think about this error message? Is this helpful for you? Would you be able to figure out from here really quickly what you need to do? I think so. I think it could potentially be enhanced by an extra message in the assert block, but I don't know if it's necessary right now. I know that we were waiting for this inventory containers element and we didn't find it, which I guess is fine. We could, like I said, enhance it with an error message if we want. And I'm going to leave it for the sake of brevity. And let's get this back. And we are done here with the red phase. Oh, and one more thing to refactor is remove this malformed URL exception, which is no longer necessary. Cool. So we are done with our very first production level test. We can literally take this and start running it in our production environments to start testing our software that we're supposed to be testing, which is really phenomenal because it's been easily less than 30 minutes and we already have a test up and running. And now all we have to do is add it to our CI system. And now from this point forward, it's going to monitor our software. Let's go ahead and do that. So for our continuous integration environment, we are going to use GitHub workflows. Why are we going to use it? Because it's extremely simple. GitHub is awesome and it's free. There is nothing wrong with fantastic free tools, and it's always important to analyze different tools and do a little bit of research before we make huge commitments. Commitments to a unit testing framework, commitments to a CI tool, commitments to a test automation library are huge commitments. Once we're in there, those are like potentially multi-year commitments. For small companies, it costs hundreds of thousands of dollars. For large companies, it costs millions of dollars per year to use and maintain those libraries. So a few hours, maybe even a few days of research and playing with different tools is critically important. So anyways, let's go ahead and jump in here. And we are gonna come here to our repository and we're just gonna click actions. And we're going to create a new workflow. And GitHub already provides all of these awesome pre-set up workflows. And one that really interests me is this workflow Java with Maven. So let's go ahead and click it. And it even already starts us out with a configuration YAML file. And look, so here it says that on push, we're gonna do this, on pull request, we're gonna do that. Everything here is looking good. You know what I don't like is setting up JDK 1.8. We're actually working on version 11, so I'm going to rename this to 11, but also we're gonna set here with Java version 11. How did I learn all this? Just by reading their excellent documentation. The documentation is so easy to read. You just hop there and then read about it. And then this other step down here, build with Maven. I don't want to build with Maven. What I really want to do is run acceptance tests is what I want to do. And let's do Maven test, and we'll add a -x for extra logging. Okay, cool. So this looks really good to me. Let's go ahead and start a commit here with this and see what comes out of it. Sometimes it works, sometimes it doesn't. Regardless, the environments provide us log information, which we just use to figure out what the problem is. All right, excellent. So we've got this now, GitHub workflows. Here you can see I just created it. So what we're gonna need to do is go back to our code. And let's see. I created a new branch here just to show you what would happen if we did a pull request. So let me check out master and pull that down. There you go, got my YAML file, and then let me check here that I got my YAML file. Yup, there it is. Here's my YAML file. Excellent. So now let's do a git push. And this doesn't exist yet, so let's go ahead and set our upstream branch. Push that, and on this push, we should have some automated tests running in our CI pipeline. Let's go ahead and take a look. So first you can see here, now we get this little yellow dot next to any commit, and that tells us what's going on with our pipeline. So let's go ahead and check here, and you can see that it has failed, and we can expand here and see why did it fail. So let's scroll down a bit. I'm gonna scroll down here. And then let's just drag this all the way down. This log is really large. And let's take a look here. So what doesn't it like? So test run, it ran a test, which is really awesome. Oh, and here's the error, misconfigured Sauce Labs authentication error. And of course, if we scroll through here more, we can find the real root cause, which is right here, misconfigured Sauce Labs authentication error. Your username none and access key none. Can't authenticate. And why is that the case? Well, it's actually really simple, because remember, we're using environment variables in order to set up our system. Now, if you're not doing this in a third-party system and you're using containers, you won't have this problem. But anyone using a cloud provider to execute their tests, they're gonna have this problem. And for any other API keys that need to be stored in environment variables. So we need to go and resolve that problem. Cool, so in order to fix this issue with user name and access key environment variables, all you have to do is in your YAML config, add values as such. Now, all this basically says is that we have this secrets object that has access to a sauce username and access key that are stored in GitHub, which I'll show you in a moment. And then those values get stored in this environment variable and this environment variable. It is so easy. I've used other CI tools and this was the easiest way to pass in environment variables. I'm super happy about it. So let's go ahead and start that commit and yeah, add environment variables. Excellent. So that's good. Let me show you where the environment variables are stored here in settings, secrets. And here you can see I created my sauce username and sauce access key, and inside of them, they actually have values. So if you wanted to add a new one, you just come here and add a new secret and then add your username and access key or whatever other information you want. And then you read it using this as the key name. So let's actually go ahead and test this out. Let's come here to our IntelliJ. I'm going to check out test 3. So now our YAML should have this. Yes, it does. Excellent. And so now let's push this up. Let's push it. And then let's come back here. Come back to our code. Look, here we have a new branch, right? Let's compare and do a pull request. And then create a pull request. And that will trigger our CI pipeline, which is exactly what we want. We want to be in this state. For our test automation framework, you can see here's the CI pipeline being triggered, and we can come here and watch it run. And it has this very nice interface with great logging, and I'll let that run while I talk about this is the state that we want to be in. If we're not writing an automation framework with the developers, which is the ultimate state, and we're doing it separately as a team of automation engineers, then we want to have a CI pipeline set up for our automation framework so that other individuals are sending pull requests to our pipeline, and that pipeline is being triggered by those pull requests and running our tests. Now, it doesn't need to run all the tests. It should run a subset of the tests, but that pipeline should be green and stay green forever. And when it becomes red, everybody should stop and try to figure out what is going on, or at least the person that just created a pull request or the person that just did a check-in that caused that pipeline to not be green. They should stop and figure that out. And that just by reading the logs. And so here you can see actually our acceptance tests have passed successfully, which is super awesome. It means everything is working. And if I look over here, you can see that I had a test that ran 1 minute ago and the test is working successfully. So congratulations. We now have a production level test. We have a production level framework, and we have a CI pipeline that runs our automated tests on push requests and on pull requests. Simply awesome, isn't it? Okay, well, so let's continue on our acceptance test driven automation journey, because you've only written one test and we've got another one to write, just so you can see how everything expands as we go down this path. So what is the next test that we want to write for our application? Well, here there is nothing really much else to do. I mean, I guess we can start testing these other users, but I don't find that so interesting and too easy to do right now, and you won't get to see more expansion. So why don't we navigate to this page, and then here we can find some very critical, simple functionality to test that is relevant for our business. And what is relevant for our business? Well, is being able to add an item to a cart, right? If someone can't add an item to a cart, how are they going to buy it? And how is our business going to make money? And then how is that business going to pay me for my job? So very critical to think about. So that's exactly what we're going to test, is when we add an item to a cart, does that item get added to the cart? So all we do is click that button, and then we can probably just check for this icon there. Perfect. So let's go ahead and do that. So let's wire up a new test. And let's call this. Should be able to add one item to cart. Excellent. And so now what do we need to add an item to a cart? Well, we need that product page, right? So, which we already have. Excellent. And of course, it'll take that driver. Okay. And then what do we do with that product page? Well, we got to open it first, right? And then after we open it, what are we going to do? We're going to add an item to a cart. Excellent. And then what are we going to do after that? We're going to assert that the item is present in the cart. So here's what we're going to do. Assert equals, and I am going to check for this number to see that this number is correct. And to do that, let's inspect this. Shopping cart badge, and this is a text. So perfect. So I'm just going to check for that text. Assert equals 1. And then we can do something like new. This will take in a driver, and then we will check here dot new shopping cart component dot get items count. What about that? That seems really good to me, right? We have a shopping cart component and we're going to get the items count. And then that will tell us how many items are in this shopping cart component. Sounds great. How does this test look? Very clean. We have a products page. We open the products page. We add an item to a cart, and then we use the shopping cart component to get the items count. Right? Super easy, very easy to understand, excellent English, using page object pattern, and no premature optimization. So let's go ahead and make this happen now. That was the red phase. Let's go ahead and enter into the green phase for making this test happen. And I'm actually going to try to go pretty fast and explain not too much so that we can accomplish a lot more in this presentation. So let's do this. This will be easy. URL, what's that URL gonna be? It's gonna be this URL, so that's done. Excellent. So add an item to a cart. So to add an item to a cart, first we have to synchronize, right? It's gonna be the first time we work with this element. So we're gonna have a web element and then shopping cart. And then we're gonna wait until visible. How are we going to identify this shopping cart? By, oh no, first we have to identify the item actually. So we're going to call this by, let's remove this, button primary. By class name, button primary. Button primary. And we're going to click it. And we actually don't even need to return it for any element. I'm just going to keep it simple like that until we decide that we want to reuse it. Fantastic. One line of code. Next, we need a new shopping cart component, which we're going to create here using our super handy IDE. Look, it even gave me a constructor here to seed with a driver. Create a field. Excellent. Now this field, we don't want it to be final. And actually, we don't even need this field. Why? Because we already have, oh no, we do need this. We have a base page. Totally forgot about our super handy base page, which makes writing a page object so easy nowadays. Look at that. Fantastic. And then of course, get items count doesn't exist. So let's go ahead and create that method. Get items count. And how are we going to retrieve it? We're going to look, let's add an item to a cart. Then we're going to click on this, and then this had a shopping cart badge. So let's check by class name shopping cart badge. Oh, it's not ID. Class name and pass in the shopping cart badge and dot get text. And of course, we need to return that. There you go. So there is our shopping cart counter. And so I believe that we are done with the green phase. Look, let's take a look. We've got a products page opening. Let's run this test and see what happens. And let's go to Sauce Labs and see that test running here, if everything is working. And something didn't work. There's a test running. And there it is. Nice. Sample test. By the way, I'm not liking these names. We're going to need to refactor that. And I also saw that the test passed because I got a little badge here on my other monitor from IntelliJ saying one test passed, but we can even watch it run here, which is always so fun. Add an item to a cart. Boom. There it is. We are awesome. And we are done with the red and the green phases for this test. Okay, so in the refactor phase, let's take a look what's going on here. And I don't see anything that I don't like. But you know what I haven't been liking is the fact that our tests don't get a test status. And also they have this stupid name. So we are going to fix that right now. Okay, to do that, I quickly just pasted in some code, which is not too bad, but for the sake of time, we've got to make this happen. So we're using JUnit rules, and we're going to use a test watcher class that's going to monitor our results. We are passing in a driver here in the before hook, and then we are using this rule to get the method name, which we are now setting down here as such. And then if we go into this class that I named Sauce Test Watcher, it extends the JUnit Test Watcher, and then it implements the succeeded and failed methods that will execute whenever the test passes or fails. And then it will just use the JavaScript executor to log the appropriate string to Sauce Lab so that it gets the results. And that's pretty much it. Let's actually go ahead and give it a run and see what happens here. Nice, so it's running. Let's take a look at Sauce Labs. Fantastic, look, we finally have a test running, and it has actually a really good test name that tells us exactly what the test is checking, and it even got a success status, which is fantastic. So I am totally happy with that refactoring. And one other thing that I wanted to do here is run it through our CI pipeline. So let's push it, and that will execute our pipeline. So let's come here, take a look. And we can come back here to our pull requests. We'll see this pull request here. Look, testing PR. You can see it's queued. We can come here, and then it's running, and we can check the details, and that's going to go ahead and execute. So there it is, our CI pipeline passing successfully and running our acceptance test. We can expand it and take a look at what it did in here. Look at that, 2 tests executed, fantastic. And there's one other thing that I want to do, which is super critical to test automation. Anytime we get 2 tests running, I strongly recommend that we make them run in parallel, because it's much easier to get automated tests to run in parallel early on than it is when you have 1,000 tests and you did something wrong. So with JUnit, it is extremely easy, and I'll show you how to do that exactly right now. Let's go to our POM XML, open that up, and all you need is one plugin, and that is the Maven Surefire plugin. I'm going to copy and paste that into here. Let's see. Excellent. There it is, the Maven Surefire plugin. It's already configured to run even methods in parallel, and it has thread count of 10, and that is pretty much it. That's all you have to do with JUnit and other frameworks such as TestNG. It's actually not that straightforward at all because TestNG is not thread safe, but with JUnit, it's super easy. So let's do a Maven test and check out if this actually works. Let's come here to Sauce Labs and boom, there it is. See how there's 2 tests already waiting, both are waiting, and so both of them are about to start running, and boom, there they go. We're running in parallel. How easy was that to do? So finally, let's go ahead and commit our changes. Add parallelization. We'll check the CI pipeline the last time, and we should be pretty much done. Pipeline is running right here. You can see our add parallelization commit that we just did. Here's the pipeline. We'll see the results in a second. All right, and there it is. Look, our pipeline complete, and we managed to even shave off 6 seconds off of our test automation. Now, it's not so important right now, but parallelization is going to become critical as we add more tests, because now, from this point forward, because we have 100 parallel threads that we can run on, every single test that we add will barely increase the test execution time, only if the test is the slowest one of the group. If it's not the slowest one, and if they're faster tests, this time will remain exactly the same for our entire automation suite until it gets to 100 tests. How awesome is that? And so congratulations, we have successfully written 2 automated tests using automation best practices, including the page object pattern. We've written an automation framework from scratch. We've ran our tests in parallel, and we integrated them into a CI system that executes on both push requests and pull requests. So how awesome is that?